family members, loved ones, and friends. Thank you for joining me with another Tech Talk with Johnnie Sanders. This is my platform, Truth and Life, and myself and others just are very thankful and appreciative of you joining and being a part. And hopefully, this is being very helpful and beneficial to you, and that you're able to actually gain some new knowledge and information regarding your own careers. Okay, this is going to be another blueprint tech talk. So just join me and again continuously send the replies and the feedback. I welcome them. Thank you so much. I appreciate it. And continuously hit the like and hit the subscribe, and we're going to just keep just cranking out these videos for you so you can learn and grow together. Okay, so this is going to be again a blueprint of microservices architecture using AWS. This is a guide taking monolithic current infrastructure into a microservice cloud infrastructure, if you will. So monolithic architecture, basically you have your user interface, your basic logic, data access layers, and your database, and they're going back and forth with one another, right? And just providing the data that way. It's very straightforward, lenient. There's not a lot of arbitrary information going in, going out. Everything is just linear, just straight. And with that, you have to wait on getting data in, and you have to wait on getting data out. Basically, you have to take your turn with that department, with this department. You have to get in line, okay? Which takes time. And that's where a lot of the batch processing came into place, where it was like, okay, I'm gonna just submit my data, and at X amount of time, then my batch file will basically get on the gravy train and get processed. Well, that's monolithic architecture. So going to a microservice architecture where there's agile data going across back and forth at the same time, and basically a user interface microservices will basically have multiple microservices going to multiple databases, right? So as many databases as you need, especially for big data, you basically have them set up to communicate and go to the specific database in the region that's closest to you, is what we normally use as a rule of thumb. So data can get to you quicker, faster. Um, and if there's anything that happens as far as anything going down, they can pinpoint which database that is and get someone to get on it and start fixing it and correcting the issue. And that database users could basically be transferred, their data would be transferred to another database that's closer to them until they can get that other database corrected. So when we're creating our microservice database, as I shared, we want to make sure that we have the client that sends a request out. It will have an identifier. It would go across the API gateway, the Amazon Amazon API gateway, and this would go to a pool of services, Microsoft microservices, right, for AWS. So it will have a management console and a service discovery. So in this microservices, there's several different tools and services that are in this particular service that will basically distribute data according to where the request is going. And it would have a remote service, right? So when you're creating a simple microservice using Lambda and API gateway, um, will basically help you with having a Lambda console to create a Lambda function. That's very important. And Amazon API gateway endpoint to trigger that function. Okay, you will be able to call a specific endpoint with any method of these type of API commands like get command, post, patch, um, and if you're familiar with APIs, you're familiar with those, right? And so this will trigger a request in the Lambda functionality. When this specific endpoint is called, excuse me, uh, the entire request basically will be passed through the Lambda function. This function will create an action that will basically send a request that depends on the method that you called earlier in your endpoint with, right? Whether it was get, update, post, patch, etc. So those commands in API requests, as I mentioned, there's delete, there's get, there's post, there's update. So you would basically, uh, depending on the request, like if you did a delete, this specific request would go to the Dynamo database table to remove it from the table completely. If it's going to the get, it will scan the table and then return the item that you requested. If you posted something, this is basically going to create a new item, right? And just like an update of a specific item with the update, which is put to update in the API. So create an API using Amazon API Gateway, right? This is going to be done using Lambda functions that is going to pass through the API gateway and have an endpoint to trigger that particular request. Now, to create an API, I'll give you a few steps for the blueprint. You're going to basically sign into AWS Management Console, open the AWS Lambda console, choose Create Lambda Function, choose Blueprint, enter the microservice into the search bar to choose the microservice HTTP endpoint that it needs to go to. Then choose Configure, okay? It's going to configure these following steps. It's going to name the Lambda microservice. It's going to give you the role to create a new role for one or more templates. The role name, policy templates, which is going to be a simple microservice permission. The API is going to create a new API. Security is going to open, choose create function, right? So when you complete this particular task and create the function, Lambda is going to create a proxy resource named Lambda Microservices under the API name that you specifically selected. And for this, it will give you an option to configure the proxy. And if you want to configure it differently, my suggestion would be go to the configure proxy integration for a proxy resource. And this will help give you more of a strategic option of resources on how you want to have this proxy actually set up. To have this proxy set up, basically, you will go to that resource and have AWS proxy integration type and a catch all method anyway. The AWS proxy integration type applies a default mapping template to pass through the entire request to the Lambda function, right? And transforms the output from the Lambda function to the HTTP response that you basically submitted early. The any method defines the same integration setup for all the supported methods. Again, anyone that you used, get, post, put, patch, delete, update, anyone, it's going to basically be able to see those commands that you submit and then respond and give you a response back. And you can test sending an HTTPS request in the console by using the Lambda function. You can run what they call a curl, C-U-R-L, a curl command to test the end-to-end experience. This is basically sending an HTTPS request to your API method and have Amazon API Gateway invoke your Lambda function. In order to complete this step, make sure you created a DynamoDB table and named it My Table. Simple as that. And basically, and if you need more information regarding how to create a DynamoDB table with the stream, there's a link. I'll put it in here so you'll be able to find it easily. And again, when you're testing your API with your My Lambda microservice function, still open in the console, choose the Actions tab, and you want to be able to configure the test event. Replace the existing text with the following. So in the HTTP method, do a get, the query string parameters, a bracket, table name, my table, and then end it with a bracket. And basically you want to save this and test. Now this has been a microservice architecture blueprint guide for you using AWS services, right? And hopefully this has been helpful for you. And again, please, I would love to hear your response back. If you need more detail, I'll provide you more detail. So again, hit the like button, hit the subscribe. And again, thank you so much for joining Truth in Life. I'm Johnnie Sanders. And remember, let's be good. Let's dare to be great. I'll see you next time.